we're dealing with the knowledge area mechanics, and we're looking at motion in one dimension, right? And we're going to look at position and displacement along a coordinate line, right? Now, in order to describe motion of an object, right? In order to describe motion of an object, we must be able to specify its position at all times using some convenient coordinate system, okay, and a specified origin. That's important. So a frame of reference, right? We need to have a frame of reference, and is a choice of coordinate axes that defines your starting point. It defines your starting point for measuring any quantity, right? Could be force, displacement, and there can only be two directions along a coordinate line. Only two directions along a coordinate line because you're dealing with motion in one dimension. Right. So if we're dealing with the x coordinate line, then it's motion towards the right or motion towards the left, right? And a y coordinate line, then it's motion up or motion down. Now let's look at position. Here we have a coordinate line, right? An x coordinate line. Now we can specify the position easily using this frame of reference. Right, so let's say for instance, I have got here the position of an object, and let's see here we've got x1, right? It's at plus 2 centimeters, and x2 we have here at the plus 4 centimeter mark, and x3 at a plus 7 centimeter mark, right? And then we have x4. Let's assume this happens, these positions change as time elapses, and here we have it at the minus 3 centimeter mark, and then x5 at a minus 5 centimeter mark. So essentially, it's what you really need is you just need to know where your origin is. And if I say, for instance, that an object is at a plus 7 centimeter mark, you will know exactly where that particular object is, right? Because I mean, we know it would be there on the line, and these, it will be there on the line and there on the coordinate line. Okay. But now let's say we're looking at position x1, right? So if I say, for instance, position right, position of, let's say, x1, right? And what is the position of x1? It is equal to plus 2 centimeters. Okay. And if we want to know what is the position of x3, x3 would be equal to plus 7 centimeters. So if I tell you the object is at position plus 7 centimeters, you know where that object is and you know on which side of that coordinate line it is, right? And let's say, for instance, if I say x4 is equal to minus 3 centimeters, right? So you'll know where it is and you'll know on which side of the coordinate line it is. So what is important here is you need to realize that what does a plus and minus tell you? Plus and minus tells you which side of the coordinate line the object's position is, right? So plus and minus tells you which side of the line the object is. Right, so you need to know what a plus and minus tells you in terms of which side that particular object is. Right. Now, let's look at the concept of distance. Okay. Distance is, say, from one position to another, it is the length of the path actually taken. Right, it's the length of the path actually taken. So let's say, and let's assume that this object that's moving and it's at position x1, x2, and x3, let's just assume that it's a straight line distance between the respective positions. Right, so let's say, for instance, if I say length, right, and let's say we say length, right, and we say x2 and it goes to, say, x3, right? So it's moving from x2 to x3, and there the distance is equal to 3 centimeters, because it's plus 7 and take away plus 4 from it, so the distance from 4 to 7 is 3 centimeters, right? And let's assume from x3 it decides to come back to x2, then what is its distance? Its distance would be also 3 centimeters, right? That is distance. It means how far it has traveled. So in total, the total distance would be 6 centimeters. So if the object goes from x2 to x3 and from x3 back to x2, we find that the total distance it has traveled is 6 centimeters. And in this case, direction is not important, because we only worried how much it has traveled. Okay. Right, now if we look at displacement, how does displacement differ from distance? Right, now displacement of an object is actually the object's change in position. It's a straight line distance between the reference point and the new position, right? It's given to you and the new position. Right, so let's look at it. I've indicated where's x1, x2, x3, and it's the same thing we have here, right? Okay, now we say if the object goes from, let's say if it goes from x2 to x3, so it's here, it's there, and it's moving to x3 here, okay? So it's going there. Now, if it goes from x2 to x3, so let's say if it moves from x2 to x3, right? We find that the displacement would be, so it moves from x to x2 to x3. So what would our change in x be? Our change in x would be x3, where it is finally, and it moved from x2, so it means it's going from there to there, right? And we see that would be, it is equal to x3 is plus 7 centimeters minus x2, which is plus 4 centimeters, and we see that that is equal to plus 3 centimeters. Okay? That's plus 3 centimeters. Right. Now, if we look at it moving from x3 back to x2, so this time it starts at x3 and then it's moving back to x2. So let's say what would our change in x be? Change in x is actually our displacement, is it not? Which is equal to, so moving from x3 to x2, right? So let's just put it here. From x3 to x2, okay? Right, and what would that be equal to? Let's just do that. So that would be change in x is equal to plus 4 centimeters minus plus 7 centimeters, and what does that give us? Minus 3 centimeters. Right, as you can see here, sign is minus, sign is plus, right? So when it took the reverse direction, it went that way, right? Now, what we can do here is we say when it's moving from x2 to x3, that is the positive direction, and when it's moving from x3 to x2, that would be the negative direction. So, I mean, positive directions could be going to the right, it's positive, and negative direction could be going to the left. Okay, and that is how we would specify the displacement. That means, so the displacement that we have has a direction, right? If it goes from x2 to x3 and then back to x2, the displacement is 0. So what we're saying is if it goes from x2, okay, x2 to x3 and from x3 back to x2, it means it hasn't been displaced, the displacement is 0. However, what we need to know, however, the distance that it covered is equal to 6 centimeters. Right, it's 6 centimeters. Okay, so distance covered is 6 centimeters. Right, 6 centimeters, right? So the distance is 6 centimeters, displacement is equal to 0, right? Because it's back at its original position. Right, so essentially what I'm saying here is, say for instance, if you travel by aeroplane in a straight line distance from OR Tambo and you go to KwaZulu Natal and you get to Kinshasa airport there and you remain seated in your let's say in your plane, and from Kinshasa you come back to OR Tambo, and let's say the distance from OR Tambo to Kinshasa is 450 kilometers. That means the total distance you have covered from OR Tambo to Kinshasa and back to OR Tambo, you have covered 900 kilometers. Whereas, what would your displacement be? The fact that you are back at OR Tambo, your displacement is equal to 0. Right. Now, let's look at this here. We have a coordinate line and we have these vectors. So let's say we got the x coordinate line, and say for instance I have this here, there's a vector, right? And let's say this vector here is equal to 10. Let me just put a value, or 9, right? Let's make it 10. It's 10, and you can see that is pointing towards the right. Okay? And if we have another vector, and this vector is let's say here, and that's also 10. So you can see both vectors are traveling, or if it's regarded as a displacement vector, then both vectors from the initial to the final position, they displaced 10 units. So that 10 units could be 10 centimeters, 10 kilometers, right? And there you have two vectors equal in magnitude and both traveling and both being displaced in the same direction. Okay, that's that coordinate axis. But let's say for instance also you got this vector and to this we add that vector, we add the two vectors here now, and we want to know what is the resultant vector. Or if I'm dealing with displacement, let's say that would be the resultant displacement. And there we have it. It's telling us if I go 10 towards in that direction and another 10, we find that the resultant is 20. S is actually the resultant vector. Right. And let's say, for instance, if I have now, leave that out. So let's say I say vector A is 10 and vector B is 15. Right. So what is our sum? The sum would be 25. Right? It's telling us that the sum is 25 and is towards the right. So vector A plus vector B. What happens if we put vector B first and then we add vector A to it? So I have vector B and then I add vector A to it like that, and then I add vector A to it. What's the sum? The sum hasn't changed. It is still 25. Right. Okay. And let's say that's along that coordinate line. What happens? We could even have that coordinate line. Right? And in that coordinate line, we could have a vector. Let's not have the value. So let's say this is one value, right? And to that, we add another vector, okay? And that is going into the that direction, and I want to know what is the sum. We find that the sum, okay, let's just do that properly. And in this case, what is the sum? The sum is, let's say there's 11 and there's 10. So the sum is 12, right? D is 5 and E is 7, so the sum is 12. That's a vector, and that is going into the upward direction. Right. And you can see that, for instance, if we decide to change the direction of this one, let's say I also make it about 7, and that one is 7. What is my sum? Because they're in opposite direction, my sum is equal to 0. Right, so here you saw vectors and how it behaves along coordinate axis, x-axis, and here when we're going up and down, how it behaves. Okay? Right, now let's have a look. Let's look at some properties. Firstly, a resultant vector is a single vector which has the same effect as all the component vectors together would have. The sum or resultant vector is the arrow drawn from the tail of the first vector to the tip of the last vector. We dealt with this in a previous video as well. Right, now let's look at equality of vectors. Two vectors, A and B, are equal if they have the same magnitude and direction. Must have the same magnitude and they must have the same direction. Right? Now, let's look at this. Okay? So, if we look at this here, we see a displacement vector that's shown. All right, and okay, if we look at this displacement vector, we see that here we have now at this point you got this vector. See here, that vector is plus 5 centimeters in that direction, plus 5 centimeters in that direction, right? We are not really, it may not be 5, it's 5 units, right? But we'll just take it as being equal to 5 centimeters. So this vector, the direction is towards the right, that vector is the direction is towards the left, and here you have now this vector where the direction is towards the left. Okay, right, so you see the directions are different, and here you've got, that's your origin, right? That's your 0, your reference from where we are measuring our vectors, right? Right, now we saying, let's just, if we look at this now, what we can see is, although this vector here is on the positive side of that coordinate line, we find that its direction is towards the right. Here we find that the vector here is towards the negative, right? Now let's look at this one. Let's look at these, right? Right, let's look at this here. This one is a vector that's pointing towards the left, as you can see, and it's 5 centimeters. This one is also a vector that's pointing towards the left, is it not? Now it's also pointing towards the left. Okay? Also pointing towards the left. And that's negative and that's negative. So what do these negative signs tell us? The negative signs actually tell us that it is going in the negative direction. If we choose that, and if that direction we take as positive, right? So that would be in a positive direction. This here would be in a negative direction. So the signs, when we're dealing with displacement, the sign here and these signs, the negative sign gives you direction. Important. Here, this positive sign gives you direction. Now, what you need to be careful about is that the direction here, the displacement, the signs give you direction. But let's look at this. This is saying that you've got a displacement that is in a negative direction, but is on the positive side of the coordinate. Here you've got a negative direction for that displacement, and it's on a negative side of the coordinate, right? So what is important there is you need to know that when you got a displacement that is either positive or negative, right? It does not tell you anything about where or which side of the coordinate line that displacement is, right? Okay, so here you have a negative displacement moving in the opposite direction to the positive, but it's on a positive side of that coordinate line. Okay, So you need to be careful about that, because if we look at this here now, we see that the plus and minus refers to directions, right? That's what it refers to. Right, so we know in this sort of situation, here A and C, so we could say that vector A is equal to vector C. They equal in magnitude and they have the same direction. Right, and as you can see now, the displacement on the negative side, right, and the positive side of the reference frame have the same direction. Right, like I said, here you have the displacement, and let's just maybe do this. Right? So we got the displacement on the negative side here, and on the positive side of the reference line or the coordinate line, they have the same direction, right? So what we need to know is just having, right, the direction of a displacement vector, right, vector will not tell you which side of the reference frame the displacement is. That's important. So you need to know what the positive and negative sign indicates when we're dealing with displacement. Here we have, instead of going moving along the x-axis, here we have this moving along the y-axis. Same thing again, here you got plus 7, right, and there 7 as well, and let's assume we're assuming that the 7 units indicate 7 centimeters along that line. It could have been 7 meters or whichever other unit we're dealing with, but you can see here and here, you'll see there's that coordinate, and you find that this displacement is in the upward direction, but it's in the positive side of that coordinate line. This one is also upward, but it's in the negative side of the coordinate line. Right. and that's important. So you can have the displacement, but you don't necessarily know which side of the coordinate line it is unless you are given the initial position. We are looking at adding of vectors. When two or more vectors are added, they must have the same units. A geometrical or graphical method can be used for adding vectors. A minimum resultant is obtained when two vectors are in opposite direction, and a maximum resultant is obtained when two vectors are in the same direction. And furthermore, when two vectors are added, the sum is independent of the order of addition. That means vector A plus vector B is equal to vector B plus vector A. And the resultant vector of A plus B is a vector drawn from the tail of A to the tip of B. We have dealt with this. Now let's look at two vectors A and vector B moving in the same direction. The magnitudes of these vectors are given. Here, the magnitude of vector A is 5, and the magnitude of vector B is 15. The direction of vector A is, so vector A, the direction is plus 5. And the direction of vector B is equal to plus 15. Here we don't have units, but we could specify the units, and this could be regarded as displacement vectors or force vectors. And if it's a force vector, then it would be plus 5 newtons, and B would be plus 15 newtons. And if we're dealing with displacement, then it could be plus 5 centimeters or plus 5 meters. So here you have the magnitude. Now let's look at if A plus B is added. Here we have vector A, that's vector A. That there is vector B. We're adding the two, and what do we get? Our resultant from there to there, from the tail of the first right to the head of the last vector, which in this case is equal to plus 20. Right, so that is a resultant vector which is given by that S there, which is a sum or equal to the resultant. So A plus B is equal to plus 20. Now if we look at A plus B here is equal to vector R, and this is vector R. Now let's change the order. And if we change the order, we have vector B which is or we could do it this way perhaps. We have vector B which is plus 15 starting from there to there to here, and to this is vector B and we are going to add to that vector A which has a magnitude of has a magnitude of 5 and it's in a plus direction. So if we add that and we have vector A here and this is vector A in that direction and it's plus 5, our resultant would be from the original to where it is. So this is vector R and that vector R would be 15 plus 5 which would be plus 20, which shows us that A plus B is equal to vector B plus vector A. Right? The rule A plus B is equal to B plus A is commutative. Vector addition is commutative. And the maximum resultant is when the two are in the same direction. If we now have these vectors moving in opposite directions, if they're moving in opposite directions, and let's have a look at that. Here we have vector B, so here's vector B moving in a positive direction, and vector A, let's say, is moving in a negative direction. It's minus A, and that's in a negative direction. What would the resultant be? The resultant would be from there. That would be our resultant vector. And here in this case, if we have vector B plus minus vector A, that would give us that resultant, and this would be plus 15 plus minus 5, which gives us plus 10, and that indicates that the resultant vector is equal to plus 10. It's in the positive direction and the magnitude is 10 and the direction is in a positive direction. So the important point here is if they in the opposite direction, we take the magnitudes if they moving in a straight line and we subtract them. When the vectors are in the same direction, we add the magnitudes. So in this case, the maximum displacement, if we're dealing with displacement, would be 20 and the minimum would be 10. Okay, now let's look at negative of a vector. When we look at the negative of a vector, here we see that we have again the magnitude. The magnitude of B is 15 and the magnitude of A is also 15. The only thing is they both 15, but the one is in the opposite direction, which means here in this case we have A, that vector A is equal to plus 15. We know it's in that direction. Vector B is equal to minus 15. Right? It's in the opposite direction. So if we have A, vector A plus vector B, and what would the resultant be? A is equal to plus 15. B is in the opposite direction, so it's minus 15, and that gives us R. So this is equal to 0, and the resultant vector is 0. Which means if you have two vectors equal in magnitude, but opposite in direction, we find that the resultant is equal to 0. And if we look at this, we see that A, B, say we have B's magnitude is the same as A's, but it's in the opposite direction. So essentially we are saying that A plus minus A is equal to 0. Right, in terms of what's being said here, the negative of a vector A is defined as a vector when added to A gives 0. For the sum, this means that A and minus A has the same magnitude but act in the opposite direction, right, as I have indicated there. Now let's look at subtracting vectors. Subtracting a vector B from a vector A is the same as adding the negative vector B to vector A. And now let's look at the rule here. Vector subtraction makes use of the definition of the negative of the vector. So we define the operation A, if we have A, and from it we're subtracting B, is the same as having A and reversing the direction of B. So when we given subtraction in terms of vectors, we need to see and be able to interpret what's being said here. This is vector A in that direction, and here we subtracting vector B, which is also in that direction. But when we represent it as vector addition, we have vector A, and vector B's direction gets reversed. So these two are equivalent. It's just more easier to visualize vector addition than subtracting vectors. So here we have now, for instance, let's say A is equal to plus 20. So A is equal to vector A is equal to plus 20, and vector B here is equal to plus 5. They both, plus is indicating that they are in the same direction. But if we have B being subtracted from A, which means what we need to do is we subtracting B from A, and it's in the same direction, so we subtracting 5 units. Here, and that's B. So that's vector B, and it's in the same direction. And if we look at the resultant is from there to there, and we find that we have A minus B is equal to the resultant, and we find that the resultant is 20 plus minus B is in the same direction, so it's plus 5, and that gives us plus 15, which means there we have plus 15. Right, that's the way to do it. But alternatively, we prefer, in terms of the definition, you have vector A plus minus, change the sign there, and then reverse the direction of the vector, and that gives us the resultant, which would mean we have 20 plus reversing the sign, which is minus 5, and that gives us plus 15. Right, we have here then that, as you can see, we reverse that sign and we show it as a vector addition, and if we show this as a vector addition, then we will have this situation here, which means we have that's A and that's B in the same direction. So when we reverse the sign, we do that, and that's now minus b. And if that's minus b, so in this case, and this is vector A, and that's vector B, and then what's my resultant? My resultant is that. And in that case, when we want to get the resultant geometrically, we say vector A plus vector B. So it's tail, head, tail, head, and that gives us the resultant. Okay. Now multiplying of a vector by a scalar. Here we have again the magnitudes given, and A has a magnitude of 10, B has a magnitude of 20, and A is in a plus direction. Here I have indicated the 10 as centimeters. So it is essentially displacement along the line, and B is plus 20 centimeters. So if we look at this, it means A is equal to plus 10 centimeters and B is equal to plus 20 centimeters. And if we say we have A in that direction, and let's say that's 10 centimeters, and I add another 10 to it, and that's also plus 10 centimeters, then my resultant would be, let's say that, from there to there, that's my resultant, and that would be plus 20 centimeters. And if that is 20 centimeters, we can see that the resultant is actually equal to 2 times vector A, which in our case would be B. So R, or the resultant vector, or in this case we could say B is equal to 2 times A. So what we're saying here is if we have a vector quantity and we multiply it by a scalar, we can get a vector quantity with a dimension that is greater than its original magnitude. So here we have it. Right, vector B is equal to 2 times vector A. So that's a vector, and if that vector, if we multiply it by a scalar, we can get that particular vector. Right, now let's look at this exercise. We have here Zara pushes a trolley in a supermarket with a force of 100 newtons to the right. Her friend Adila pushes against the trolley in the opposite direction with a force of 60 newtons. What is the resultant force? And take right as a positive direction and give the resultant force. So here we are told to take right as a positive direction and give the resultant force can be done geometrically or algebraically. So let's say here we have a trolley and we have Zara pulling in that direction, and that's, oh no, Zara is pushing it, so that would be plus 100 newtons. There's Zara, and this side is Adila, and that is minus 60 newtons, since we say that direction is positive and the reverse is negative. So in this situation, if we have Zara moving in that direction with a force of plus 100 newtons, right? That is Zara. And Adila moving in that direction, minus 60 newtons. What is the resultant? The resultant is from the original to the actual, means that's the resultant, and the resultant would be equal to plus 40 newtons, and the direction is towards the right. If we look at it algebraically, we would say a resultant R is equal to Z, Zara's force, and Adila's. Zara's is plus 100 newtons, Adila's is in the opposite direction, as you can see, it's minus 60 newtons, and that gives us plus 40 newtons, plus indicating that the motion is towards the right. Let's look at the next one. Here we have three friends, Andile, Bata, and Cynthia. They have a tug of war. Andile and Bata pull to the left, each with a force of 500 newtons. Cynthia pulls to the right with a force of 850 newtons. What is the resultant on net force? So we say we have here, let's assume that's the point of the tug of war, and we have one person pulling there, it's Andile, and let's say the other one pulling there is Bata. And let's say that direction is chosen as positive, so this is towards the left, so that's minus 500 newtons, and that's minus 500 newtons. And then we got Cynthia pulling in that direction is plus 850 newtons. Right. If we look at this and we now do this algebraically, we have resultant R is equal to Cynthia's plus Andile plus Bata. Right? Now here we have Cynthia is in the plus direction, so it's 850 newtons plus, and delay is in the opposite direction, so it's minus 500, and beta is also in that same direction, so it's minus 500 newtons, which means plus 850 newtons, and minus 1000 newtons, which says it's minus 300. So 1000, so it's minus, let's just get that right. We had 850, so that's 1000, and that gives us, just correct this, and that gives us minus 150 newtons, and that minus is indicating that it is towards the left. Okay. Okay, let's look at the next one. Vector A is plus 20 newtons, vector B, both have the same magnitude, but they act in opposite directions. What does plus and minus sign indicate, and compare the magnitude of force A and force B? Okay, there we have plus and minus sign indicates the direction of the force, and both are 20. When we look at the magnitude, we're not worried about the direction, so magnitude of A and vector B are equal. Right, now let's look at the next one. It says determine the maximum and minimum resultant of two forces, 10 newtons and 7 newtons respectively. We have dealt with this earlier in our explanations, but have a look at this. We now see that if we have we choose it as our positive direction. If we have 10 newtons in that direction, and we have plus 7 newtons in that direction, then our resultant would be from there to there, which is plus 17 newtons. That would be a maximum. if we look at if we look at the one force acting in that direction, it's 10, and the other moving in the reverse direction, and let's say is minus 7 newtons, then the resultant would be there, which is plus 3 newtons. So that would be a minimum. So when vectors are moving in the same direction here, we get a maximum. When vectors are moving in opposite direction, we get a minimum. And if these two vectors had equal magnitude, then the resultant would have been 0. Now let's look at the next one. Two vectors have unequal magnitudes. Can the sum be 0? Explain. So if they have unequal magnitudes, the sum cannot be 0, right? Only if they are equal, only if the vectors are equal in magnitude. And they have opposite directions. Okay, I have just written all in capitals. Now, what do the signs plus and minus of the following physical quantities mean? This is important, and you need to take note of this, because in subsequent lessons we're going to be dealing with the sign of vectors, and you need to know what they mean under specific context. So when we're dealing with position, that means when we're dealing with position, the plus indicates the side of the axis that we can find a particle. So if the position is plus, we mean the particle is on the positive side of the axis. And if it's negative, it indicates that the particle is the negative on the negative side of the axis. Plus indicates the side of the axis that you're going to get the particle or object. And then displacement, see, slightly different here. Displacement, what does a positive mean? Positive indicates the direction. Direction of the vector. Whether we're dealing with displacement or force, and this side it indicates the side, this side it indicates the direction. There we have it. See you the next time.